Okay, so we talked a little bit more about volcanoes last time. So this time we're going to pivot a little bit to earthquakes. And then we'll be back at the end with some more volcano stuff. So the for the focus of an earthquake, oops, that's where the force of an earthquake is felt most strongly. The focus is also where it starts. And also where it starts to move. Remember how, like, with the plate tectonics, um, they're all there moving around. This is when the focus is where there's a sudden movement along the earth, and then it's strong enough to start an earthquake. So, since it's where the earthquake starts, it's also where you'll feel the force the most strongly because it's where the power is focused in. So, let's say, for example, this map that has, there's Los Angeles right there. So, this earthquake happened, the focus started in Northridge, right? So, that would be the most powerful. And then it would kind of like send out, it'll still keep moving, but the further away from the focus, the weaker the power would be.
Do you remember what was the magnitude of that earthquake?
I can look it up. Let's see.
Or maybe I should have looked it up. I thought it was like a 6.6 or something, 6.5.
Possibly. Oh, this was a 7.8 magnitude.
7.8, really?
Right. On the San
Really?
Andreas Fault in 1857. So this was a while ago.
Wait, are you talking about I was asking about the
Oh,
Northridge
wait, the
earthquake.
Northridge. I'm reading the wrong one.
I was like a 7.8. I was like,
No, that's a
wow.
6. So this was 1994
Yeah,
and yeah, 6.7.
6.7.
I'll even
Okay.
put that too.
That's still, that's big.
Put it there just for reference. I was reading something else. This one was in, yeah. And then the second area where you can feel the earthquake most strongly, that's the point where the rock breaks underground. Okay, so with that, magnitudes are also how powerful the earthquakes are. We have an example. So let's say earthquake A. Let me make this bigger so you can see. Yeah, weird. Let's say earthquake A has a magnitude of 4.2, and then earthquake B has a magnitude of 6.1. So earthquake B would be stronger, creates more force, and let's see. It also had more energy to release, which gave it more force. And what gave it more force was also because there was more movement. So the more movement that there are at the focus, the more energy will be released. So the bigger the impact, and the stronger the earthquake would be. And kind of like how you saw up here in this picture with the red, orange, yellow, green, the earthquake, the force travels through kind of like a wave, and that's called seismic waves. They travel outwards. Oh, let me put the question too. Outwards in all direction. The earth quakes. Focus. So kind of imagine. Wait, let me put the picture in too. Oopsies. We'll discuss this more later, but Earthquakes the force travels in waves. Kind of think of how oceans have waves. So these are kind of more like waves we can't see, but we can feel. And we'll go into this more, but I'm going to show you a video just with how these seismic waves causes earthquakes. I'll go back to the notes, but we're just going to watch a quick video. Let's make this a better quality.
Earthquake waves, more often called seismic waves, are vibrations generated by earthquakes that continue to spread within Earth or along its surface. Earthquakes generate two main types of waves: body waves, which travel inside Earth, and surface waves, which travel on the surface. Body waves and surface waves can also be divided into subcategories, like P, or primary waves, a type of body wave that moves quickly through solid rock, liquids, and earth, and can sometimes be heard by animals, explaining why dogs may bark right before an earthquake hits. Next come the S, or secondary waves. These body waves are stronger and travel farther, so more people feel them during an earthquake. As they travel, they move rock particles up and down or side to side. After P and S waves come surface waves, which follow body waves and cause the most damage. Surface waves include the fast Love waves, named for British seismologist A.E.H. Love, which create horizontal movement, and the slow but larger Rayleigh waves, named for British physicist Lord Rayleigh, which produce most of the ground movement felt during an earthquake. Seismic waves naturally occur when energy being stored in Earth's crust is suddenly released, often when huge masses of rock pressed against each other fracture and slip. Earthquakes begin when these rocks slip, triggering the waves, and with them, the potential to topple buildings, rupture gas lines, and start a tsunami.
So we'll talk more about, the waves after. So I'll give you some time to write this down. Right. So whatever wave that happens also affects how much, how powerful the force will be, because each of them travel in a different way. So first, we'll talk about the P waves, which are the ones that happen first. Even though they happen first, they cause less damages than the ones that come after. So compared to the S wave, P wave is less. Okay, I'll screw up when I'm done. It causes less damage than an S wave. How I remember how the S wave move is it kind of looks like an S, right? Like an S right here, but horizontally. S wave. So the P waves are the fastest type of size wave. So it kind of seems like the faster the waves go, the less powerful they are. Because the S wave moves slower, but they're more powerful. Let me move up so that you can get the other stuff. Let's see if I can make smaller. Okay, I'll temporarily take this out, but I'll put it back later. Just so I can add more things. Next, we'll talk about the S wave, the one that was more powerful. So it is slower than a P wave, but it causes more damage. P wave. Find one that'll take up less space. Then the last type of wave. I know there was a lot of waves that they talked about in the video, but we just know about the P wave, need to know about the P waves, S waves, and the surface waves. So the surface waves are the slowest type size waves, but because they're the slowest, they're also the seismic wave that causes the most damage. So that's the other two, the Rayleigh and the Love wave. But you don't need to know about their names specifically. Just that they're a type of surface waves, and surface waves are the most powerful ones that cause the most damage. Okay, I'll temporarily make this smaller. I'll make it bigger later. Okay, I might be going a little fast, but I'm trying to cover as much as possible so you can have more information for your test. So going back to volcanoes, earthquakes and volcanoes happen kind of at similar areas. So they both happen at subduction zones. Remember, subduction is just another word for movement in the plates. And where both of them can happen is also amid ocean ridges. So if you remember what that is, that's where there was a divergent, also called like ocean floor spreading, we've called before. By divergent plates. Is that diverging? They're moving away from each other. Let's see. I tried. It's just not gonna go in. Okay. I'll move it down like this then. We can see it. I'll just show you the picture and then I'll move it back to the notes real quick. So it looks something like this, right? Because there was the divergent plates going away from each other. There was a little crack because, you're spreading it kind of like slime. You're pulling it apart, it breaks. And then the magma is going to kind of seep through the cracks and set the stage for a volcano or an earthquake, because they are very similar to how it starts. Just make it really small there. And then one more I'll add is convergent and divergent plates. So just to add on, the more that divergent plates are happening, the more ocean floor spreading we're having, and the more ocean floor slash sea floor. Sometimes you'll see ocean floor, sometimes you'll see sea floor. They mean the same thing. So the more sea floor spreading there are, the more underwater volcanoes there will be. And remember, that's why we have that ring of fire all over the Pacific plate, around the Pacific Ocean. All right, so all it'll take, since there's already magma down here, all it'll take is one of the waves that are powerful enough to kind of happen, right? Because they're both affected by the plate tectonics. All it takes is just a strong enough wave to shake up the magma down here. Remember, like the soda bottle, we shake it up. There'll be, the more movement there are, the more energy there'll be, and they'll have to release the energy somewhere, and then that's causes the eruption. Okay, let me add just one more and we'll be done. So what's different though, earthquakes and volcanoes both happen at convergent plates, happen at divergent plates, subduction zones, mid-ocean ridges. One more location that's most likely or more likely to have volcanoes that won't have earthquakes is a hotspot. Where spots are located. And you think like volcanoes are like really hot? Hotspots are where you can most likely find the volcanoes. Where plates collide with each other. So that's the convergent plate. It's just another way of saying it, so don't be tricked by that. And where plates pull So where plates pull away from each other, that's the same thing as divergent plates. Okay, so once you're done, you can go ahead and take Unit 4 of the test. That's 4.3.2. Use the notes that we took today to help you and the notes we took from the last class. And those of you who still need to take 4.2, go ahead and do that. Try to catch up. For 4.2, you'll be using last class notes. Here, I'll move it up for you to see. So if you need it, let me know. So not the test review. Yeah, the last. Yeah, with the Ring of Fire. So then that was like last week's notes. Yeah, last week's notes. So that's also a 2-part.